Hello again, it is Dr. Pitcher here, and for this lecture in Chapter 5 we're going to take a look at the R and S nomenclature for chiral carbons. So R and S nomenclature is also known as the Cahn-Ingold-Prelog system, just in case you see that name. And so we'll take the following steps. First of all, we're going to assign a priority to each group attached to our chiral carbon. See if I can write chiral correctly. So let's just take as an example, we'll take this molecule here, and I'll go ahead and I'll hold it. This is one of the ones that we looked at last time. And so I'm going to have my hydrogen attached to my carbon, attached to a chlorine. The bromine is out front, and the iodine is in back. Now there are some rules for assigning these priorities. The priority is based on atomic number. So higher atomic number equals higher priority. All right, so in this case, our highest priority, our highest atomic number is iodine, so that's going to be a 1. Next is bromine, that's a 2. Chlorine is 3, and then hydrogen is 4. Now, what happens if we have, let's say, a tie? So let's say we have the following. We've got CH, CH2, CH2, CH3, CH3 in front, and then in back we've got CH2, CH3. Now these are 4 different things, okay? Even though the first atom out is carbon in 3 of them, these are still 4 different groups. We have a methyl group, an ethyl group, and a propyl group. So this carbon is chiral. It has 4 different things. So in case of the ties, or in case of ties, so we have carbon, 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 we'll go out 1 more atom. And then we'll use the priority rules that we did in step 1 here. And with the addition that 1 higher priority atom, we'll say beats any number lower priority. We'll look at some examples of those. So it means that, you know, if we have 1 carbon, that is higher priority than 3 hydrogens. So if we go out 1, we'll see we have carbon, carbon, carbon. So that's a tie. We'll go out another. Here we have hydrogen, hydrogen, carbon. Here we have hydrogen, 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 and here we have hydrogen, hydrogen, carbon. Sorry, hydrogen, hydrogen, carbon. Wait a minute, hydrogen, hydrogen, carbon. It's a little easier if you draw out the hydrogens. I haven't done that. Here. But, in fact, maybe I'll go ahead and do that right now. So H, C, C, H, H, H. Oops, that should be a dash. C, H, H, C, H, 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 C, H, H, C, H, C, H, H. All right, so let's try this again here. We know that hydrogen is going to be our lowest priority, so I'm going to call that a 4. We go out one carbon, or one atom, and we've got carbons. Those are all a tie. So now we'll go out another atom. Here I've got 3 hydrogens. Here I have 2 hydrogens and a carbon. Here I have 2 hydrogens and a carbon. So 2 hydrogens and a carbon is higher priority than 3 hydrogens, because a carbon is higher than a hydrogen. So this methyl here is our 3rd priority. Now these guys are tied, so we have to go out one more, and I've got 3 hydrogens versus a carbon and 2 hydrogens. So this propyl group has the highest priority, so this is 1, and then the ethyl group is 2. Okay, so that's what happens if you have ties, and the best way to, try this out is simply to practice. Now, what happens if you have double bonds? So if you have double bonds, you treat those double bonds as if they were bonded to the same atom. So let's write that out. In case of double bonds, treat as multiple single bonds to same atom. So what is that going to look like? Well, let's do this. Let's do carbon, hydrogen, C, double bond O, H, C, H2OH, CH3. So in this case, we're going to treat it as follows. We'll have our carbon with the central carbon with the hydrogen. We'll have a carbon here, and we're going to treat it as that. And then we actually treat the oxygen as being bonded to 2 carbons. And then here we'll have C, with the wedge, H, H, O, H. And back here we'll have C, H, H, H. Okay, so now I know my hydrogen is 4, my methyl is 3. So I've got tied, I've got carbon. If I go out one more, I've got 2 oxygens and a hydrogen. Here I've got 1 oxygen and 2 hydrogens. So this guy is priority 1. So that's 1, 2, 3, 4, like so. Okay? And you can take a look at the text to see some examples. And I do recommend this. Let me just pull out that page out of the textbook. So here's the, this is what it's treated as. And here's a double bond would be treated as this. And then a triple bond would be treated as each carbon's attached to two carbons. Okay, so it takes a little bit of practice, but it should be, once you get the hang of it, relatively straightforward. All right, so now what happens when you've done your assignments or done your prioritization? What do you do next? So step 3 here is going to be, you will rotate the molecule in space. So let's just say arrange molecule, let's say rotate molecule. To put lowest priority group in back. So that will be dashes. So for example, taking a look at our first example here, I had hydrogen, carbon, chlorine, bromine, iodine, and I know 1, 2, 3, 4. So I want to rotate this, and so right now it has this orientation. I'm going to rotate it to put the carbon, or sorry, the lowest priority in the back. So that's going to be carbon, and then coming out, we'll have a bromine up here, coming out, we'll have a chlorine there, coming out, we will have an iodine there, and then in the back, maybe tilt it a little like that, is our, whoops, not our iodine, our hydrogen, sorry, H. That should be a hydrogen there. Okay, here, let me draw this a little better. Carbon, BRICL, and then H is in the back. Now, I could simply put it in this orientation. Okay, so I've gone from here, and I could rotate like so. So we'll have carbon, I'll have my bromine in the same plane as the chlorine, my iodine in front, and my hydrogen in back. This is how the text describes it, as if you were looking like straight on and the hydrogen was pointing straight back, which is really the ideal way to do it. But you can do it if you just have the one group in the back. It's still going to work. So let's add in the priorities. 1, 2, 3, 4. 1, 2, 3, 4. And then what you'll do is draw a circle or draw an arrow going from the highest priority group to the next highest to the third highest priority. So we'll say draw arrow starting at highest priority group going to second, then third priority groups. Okay, so in this case, I've got 1, 2, 3, so I'm going to draw an arrow like that. So 1, 2, 3, like that. I'm ignoring the hydrogen, that's in the back. You can do the same here, 1, 2, 3. In both cases, I have a clockwise arrow. So if arrow goes clockwise, that is going to be R. And if the arrow goes counterclockwise, that will be S. And one way I like to remember it is if I draw my R here, I have to go clockwise to make the loopy part of the R. And if I draw my S, I have to go counterclockwise to make that top part of the S. So this particular molecule would now be named R bromo chloro iodo methane. And then its enantiomer would be the S version. Okay, and if I, again, oriented it, I'm going, my order here is 1, 2, 3, so now I'm going 1, 2, 3, I'm going counterclockwise, so that's S. So you can see that this is S. In fact, that's one way to pick out enantiomers is, see if two molecules are different things. If you do an assignment of a chiral carbon and the assignment is different, if you just have the one chiral carbon, and if the assignment is different, then you've got a pair of enantiomers. So give this a try. This is something that you will need to do on the quiz and the exam. All right. So next time, I think I'll actually revisit something with optical activity, and then after that we'll look at some other types of stereoisomers, ones that have multiple chiral carbons. Until next time, stay safe out there. Bye now.